Okay, everyone. So, again, I'd like to welcome everyone to Clyde Road and everybody dialing in on the webcast to our seventh monthly lecture of the season. For those in Clyde Road, if you can switch your phones to silence, um, take notice of the fire exits at the main door and to my left. And again, if you could sign off on the attendance sheet, that'd be great. For those joining for the first time, the Energy and Environment Division hosts 7 monthly lectures dealing with the topics of energy and the environmental effects of energy usage and production. Tonight's lecture is titled An Insight into the Great Island Generating Station and will be presented by Padraig Dunleavy. So Padraig is a chartered engineer and the station manager of the Great Island CCGT plant owned by SSE. So Padraig commenced his career with ESB in 1991. After a number of years, including a 5-year spell with ESB Networks, Padraig transferred to the Great Island plant in 2006, where he worked as station manager. And Padraig has supervised the selection and training of the operations and maintenance team for the new 464 megawatt CCGT plant and managed the start of commercial operations of the new plant. And at this stage, I'll hand over to Padraig.
Okay,
Thank you, Padraig.
Hello, great to be here this evening. And first, I'd just like to thank the Energy and Environment Division very much for the opportunity to speak to you all this evening. It's a very great privilege to have this opportunity, both on behalf of myself and on behalf of SSE. So very, very happy with that, and thank you very much for that. So I'll talk tonight about the Great Island Power Station project, a bit about the CCGT itself, and a bit about the construction process and some of the issues and some of the interesting problems that arose around that and how we dealt with those. So to begin with, you can see 2 images there, and the image on the left is taken a number of years ago, and it's the old heavy fuel oil plant in operation. You can see that the one of the stacks, you can see the emissions coming from it. That's the stack from Unit 3. So there were 3 units in the old heavy fuel oil plant, and in that photograph you can see that Unit 3 is in operation. To the right of the Unit 3 and right of the old plant, you can see a large area there in the foreshore, which is basically unoccupied. It's basically empty space. And you can see the other image, the image on the right hand side there, the status in 2016. It's actually taken, that photograph was taken slightly earlier than 2016 while construction was still underway. But you can see in the space where you had the empty foreshore area, now you can see that the CCGT has been constructed. So that's where we built the CCGT immediately to the east of the existing station in some available empty space that was there. You can see that it's you'll see in some of the photographs coming up, you can see that it's actually quite a tight space, and that posed some interesting construction site issues for us during the construction. And more about that in a minute. So just to start with the location, you can see there in the centre of the map there, you can see the site location. It gives the grid reference for it there. And you can see from the map that the site is actually at the confluence of 2 rivers, at the confluence of the Barrow that's coming down to us from New Ross, and the confluence with the Sure coming from Waterford. So in the station itself, you're standing in County Wexford, and you can look across at County Kilkenny and in the other direction at County Waterford. It's a site of particular environmental interest. You can see a number of the sensitive environmental areas there that are marked. In particular, the actual waterways themselves are a designated area of particular environmental interest. So it's an environmentally sensitive area, and it was an environmentally sensitive project. So the background is the original heavy fuel oil plant on the site was originally commissioned in 1967 by ESB. And the old heavy fuel oil plant had 3 units, 2 60 megawatt units, 2 60 megawatt electrical output, a 120 megawatt unit, and they were all fueled by heavy fuel oil, and they were conventional Rankine cycle units. They had accumulated up to 135,000 run hours by 2008. That was on Unit 3. Units 1 and 2 had run hours maybe about 10,000 less than that, about maybe 125,000 or so. And in 2008, as part of the moves towards market liberalisation, ESB was required by the Commission for Energy Regulation to move towards the disposal of a number of its generating assets. And ESB tendered for disposal of the site with a number of other assets, which included Tarbert generating station and Road and Tonamore peaking plants. So there were four assets for sale at the time. Originally, when the site was mooted for sale, we were looking at the closure of the site in late 2008, maybe in early 2009. However, after the due diligence by external parties, a number of parties expressed an interest in acquiring the site, but actually acquiring it as a going concern and continuing to operate the heavy fuel oil plant until such time as the site was repowered and the new plant, whatever it was, would have been built. And that's actually what happened in the end. And through that process and through the sales process, Endesa, a Spanish utility, acquired the site in January 2009 and established a wholly owned Irish subsidiary, Endesa Ireland Limited, which was the asset holder. So Endesa, the parent company in Spain, in around the time of the acquisition, we were going through the Great Recession at the time, and that had impacted the Spanish electricity market particularly heavily. It also impacted the Irish market particularly heavily. And there was a similar reduction in Spain to what we experienced in Ireland. The overall peak demand for electricity in Spain during the time of the recession reduced by approximately 10%. Endesa in Spain had a number of projects at the time that were in the pipeline, in particularly CCGT projects, and had already entered into a contract with Mitsubishi for the supply of a powertrain when the recession occurred. So therefore there was an opportunity, there was a plant that Endesa had contracted to build and which was now a cancelled project in Spain. So there was opportunity for Endesa Ireland, and when the project was cancelled, the equipment in one of the there were two projects, but the equipment from one of the cancelled projects was actually diverted to the Great Island project. So some of the modules for the heat recovery boiler had already been delivered to Spain, and the powertrain itself was under manufacture in Japan at the time. So the equipment was diverted to us, and we said thank you very much, and moved to begin the permitting process. So as part of that, we secured planning permission in 2011. The IPPCL, the environmental license for the site, was done by means of a modification of the existing IPPCL on the basis that the change of the emission points, quantity of emissions, and a lot of the other groundwater monitoring points, a lot of the license issues around the site would remain the same. So we dealt with it not on the basis of a new IPPCL, but on the basis of a modification to the existing one. So the actual physical works, project groundworks, commenced in early January 2012. We have some initial contracts in putting in some road works, clearing a timber for the contractor laydown area and so on. All of that started in January 2012. And 3 years and 4 months later, we went into commercial operation on the 17th of April 2015. First fire having had occurred in September 2014. So the heavy fuel oil plant remained fully operational until the CCGT was in commercial operation on the 17th of April and closed down the same day. So the contracts, overall expenditure was 350 million euros. And the companies that are involved, Mitsubishi Heavy Industries, which supplied the powertrain and the HRSG. They contracted the HRC from Nutter Ericsson of the USA. Dragados Cobra Initech, which is their constituent companies of the ACS group, they were contracted to supply the balance of plant equipment, the mech and elect, and the project integration. They were in charge of the project integration. Hyundai supplied the generator transformer. NKT supplied the 220 kV cables. GasLink provided us with our gas connection, which was a 41 kilometre extension of the gas network from Bonlusk above ground installation in County Kilkenny. And ESB Networks constructed a new 220 kV GAS to enable us to offload the station. So one of the points about the project, which was quite interesting and different from projects that you would normally undertake, is that it was very much a multi-contract situation, which really arose from the need to reverse engineer a contract structure on the basis of the cancelled equipment in Spain. So that's why we went about it in a slightly unusual fashion. And one of the issues around that, obviously, is that there was a lot of additional risk associated with the management of a lot of interfaces. You had particularly the interface between Mitsubishi Heavy Industries and Dragados Cobra Initech. So the spec for the station, it's a gas turbine combined cycle, a single shaft machine. The main fuel is natural gas, and the secondary fuel is distillate. Guaranteed CC output, that's the gross output, is 470 megawatts on gas at standard temperature and pressure. The gas turbine type, it's an M701F4 machine, which will produce 310 megawatts gross on firing on gas. And the steam turbine, it's an MHI steam turbine, tandem compound double flow, and it will supply 160 megawatts gross when firing on gas. The distillate output is smaller by about 30 to 40 megawatts. The generator type, it's a static excitation type generator, thyristor controlled, and it's hydrogen cooled. The HRSG, it's a Nutter Ericsson horizontal flow HRSG. It's a triple pressure system, HPIPLP, with reheats. The condenser is seawater cooled, single pass, and it's titanium tubed. And the control system is a diaceses netmation system. So just moving on to an initial look at some of the images when we were under construction. And the image on the left, you can see covered in the grey tarpaulin is the combustion turbine itself, and it's arriving. It's mounted on a multi-axle transporter unit, and in the position you see in the image there, it's just driving off the ramp onto the foreshore, having arrived on site by barge. So you can see the barge just behind it. More on that in a minute. I'll explain a little bit more about that operation in a bit more detail. The image you can see on the right hand side is the HRSG itself during construction, and you can see on the right hand side of the image, you can see the rectangular OPE there, and that's the connection point to the back end of the combustion turbine. So the hot gas is entering through that rectangular OPE, or will enter through that rectangular OPE on the right hand side. And on the left hand side of the HRSG block, you can see the stack. You can see the cylindrical sections of the stack there as that's beginning to be erected. So a little bit more about the gas turbine itself. It's an F4 machine design. We have an on-load changeover capability, so we can change over on-load from gas to oil, back to gas as we want. We can start on oil, we can start on gas. We've two-stage HEPA filters. It's high-efficiency filters, which is to improve efficiency. We don't have a bypass stack, so we have we've no simple cycle or open cycle facility. Everything goes through the HRSG, and we always operate in combined cycle mode. The gas turbine itself has a casing cooling fan installed as a feature of this particular Mitsubishi machine, which is to prevent differential cooling after shutdown, which would cause a catback, which is basically an axial arching of the machine. We have an online blade washing system for the GT compressor to improve efficiency. As you know, the fouling of the compressors is one of the main sources of efficiency losses in this type of machine. We have an anti-icing system which we installed. This is one of the things we were most insistent on putting into the specification, because in Great Island in 2010 we had been badly affected by the winter freeze up that occurred in February of that year. We went down in Wexford, we went down to -16, and it impacted. We had on the old heavy fuel oil plant, we had a lot of damage to the auxiliary cooling water system. A lot of the outdoor equipment, particularly the induced draft fans on the old boilers, were affected by freezing of the water in the cooling jackets of the motor bearings, of the motor and fan bearings, and basically burst the bearings apart. So we installed a lot of precautions at that time for the old plant. And also at that time, one of the problems that affected the country nationally in 2010 was that a lot of the CCGTs were taken out of action by freezing of dampness in the air filters. They had a kind of a freeze and a kind of like a sheet frost across the air filters, face of the air filters. So part of that, to overcome that, we insisted on the installation of an anti-icing system, which basically takes a bleed from the one of the stages, I think it's the 5th stage of the air compressor, and basically vents that back out to a series of distribution pipe work outside of the just upstream of the air inlet. We have a purge air system, which is to prevent reverse combustion when we're operating on oil. Water injection system to reduce NOx emissions when we're operating on oil. We don't need or use it when we're operating on gas. And we have separate fuel oil and gas skids. So the steam turbine, it's a tandem compound turbine, double flow. The two blocks, the HBIP block and the LP block. We don't have a clutch, so we operate. We spin up the turbine, the steam turbine during the GT run up. For starting steam, we have an auxiliary boiler. We have two auxiliary boilers, in fact, 200% duty boilers, and the auxiliary boilers, they can run on gas or diesel, and we need those for startup. The control valves on the steam turbine, they're of 3 different types: plug type valve for the HB control, swing plug for IP turbine control, and LP control valve is a butterfly valve. We have active clearance control on the seals for greater steam sealing efficiency, and stellite strips on the L0 blade of the LP turbine for erosion prevention. Now, there's particular features of the development of Great Island. We were able to make reuse of a lot of the civil structures. We reused the CW pump house in its entirety, and in the pump house we installed 2 new cooling water pumps and 2 new auxiliary cooling water pumps. So that was a tricky operation that we had to do, because we had to maintain continuity of supply of cooling water to the old heavy fuel oil plant whilst we were doing that. We managed to do that, and we reused fully the cooling water inlet pipework system, which comes from an inlet structure which is located on the station jetty. which ducts to two subterranean pipes which come into the sumps in the cooling water pump house. So we reuse the intake structure in its entirety. Then the discharge from the cooling water pump house, we actually buried a new pipe. A new pipe was buried along the shorefront. We decided not to use any of the pipe work under the old heavy fuel oil plant, although there was one redundant pipe. But the problem with it was that it was through the floor plan of the heavy fuel oil plant and would be compromised by future demolition, so we decided not to use it at all and buried a new pipe. The heavy fuel oil tank, we have 5 old heavy fuel oil tanks in the plant, and we converted one of those tanks to store diesel, which is the backup fuel for the CCGT. It's an air grid requirement that we hold 5 days worth of fuel, and we hold that in tank number 4, which was the tank that we converted. So during the commissioning of the diesel tank and during plant commissioning itself, we used quite a bit of diesel. So we had 3 seaborne fuel deliveries during the commissioning phase. It was interesting. There was a lot of logistics involved in that, because one of the issues is that the fuel that we use, it's a specific high grade low heavy metals fuel, not readily available in Europe. It had to be transshipped from the US. And the problem is that due to the sandbar at the port of Waterford at Duncannon Beach, there's a limitation to the size of vessel we can get in. So we're generally limited to fuel loads of about 25,000 tonnes. So the fuel had to be transshipped to Rotterdam, stored in Rotterdam, and then brought to Great Island in three deliveries. So there's a lot of time and cost involved in getting that into us. So the current status is that we've been available since the 17th of April 2015, when we went into commercial operation at 5:55 a.m. on the 17th of April. We had the official opening ceremony by An Taoiseach and the Kenny TD on the 12th of June 2015. And since we went into operation, we've produced over 4.5 million megawatt hours to date. We've just reached 13,000 operating hours exactly, which we reached last Saturday week. And the maximum output of the machine has been tested at standard temperature and pressure. We can export 464 megawatts. Obviously, we can go higher in winter when the air is cool and dry and the seawater is cool as well. We can go much higher, probably 470, 475, pushing 480. And as we speak, we've reached 13,000 hours. Our first combustion inspection is actually underway as we speak. Mitsubishi Hitachi Power Systems Europe is carrying out the combustion inspection on the powertrain, and we're doing a lot of associated works, statutory inspections and repair jobs on the balancing plant. We hope to finish that at the weekend or into early next week. So you see a photograph there of the turbine hall. This is during construction. So we're standing, and we're looking in an easterly direction as we look at that. And you can see, first thing you can see is the rectangular exciter block there, followed by the generator, and then followed by the steam turbine enclosure, and the GT enclosure is at the back of that again, just at the very end of the building. So the issues that we faced, particular issues that we faced in construction, the approach to Great Island is quite unusual. The station was built in the 1960s, and it's built at the end of a very, very narrow road. It's just an L road, basically, quite a narrow road. We had to get a lot of people in. We had to get a lot of materials in. There was a lot of road traffic during that time. So that was a particularly sensitive issue, particularly with the local community in Great Island. The work went on over a 3-year period. We had 1,200 individuals worked on the site at one time or the other, because we inducted 1,200 individuals to the construction site. And the peak number of workers on site was 800. Abnormal loads delivery was very, very difficult. We couldn't get the large loads, the GT, the ST, or the generator transformers. We couldn't get them, the generators. We couldn't get them down the road into the station. It was impossible. So they were delivered by sea. They were delivered by barge. They were transshipped. They were shipped first, international shipment to the port of Waterford, which is just up the River Suir from us, is about 3 miles away. And then it was transshipped from the port of Waterford to the site on barges. We modified the jetty. We removed one of the bridge sections between the main body of the jetty and one of the dolphins to create a space where the barge could get in underneath, and created 4 anchor points so we could anchor the barge safely, and then offload the barge in a row operation. And we see some photographs of that in a minute. So that was particularly tricky. The site was actually quite confined, because you can see from some of the images there that the actual area around the site, around the GT itself, is very, very confined, and also the discharge canal for the CW discharge canal runs through that as well, which makes it more complicated. So coordinating people, loads, materials, everything in that site was required a lot of work and a lot of coordination. And again, as I mentioned earlier, the contract structure, because it wasn't an EPC type structure, there was a lot of interfaces, and there was a lot of work done to coordinate that. So back to the images there, you can see what I was talking about the tightness of the site, a lot of crane activity. In that photograph, you can see there in the left-hand side of the image, you can see hoisted by crane. You can see one of the tube banks. That's actually one of the tube modules for the HRSGs being lifted up, and basically what that is lifted up and over the top of the frame of the HRSG, and then just lowered down into position. And you can see the top of the tube module there. Basically, it splays out at the top and basically sits down on the frame of the HRSG to which it's bolted. We had a problem subsequently with in plant operation about 18 months in with the HRSG. It was quite an unusual problem in that one of the flue gas thermocouples was actually, it was a design issue, was located in the wrong place. It was actually located too close to one of the tube banks. So when the HRSG heated up, the tube bank shifted sideways and actually began to rub against the thermocouple pocket, and in the end, the thermocouple pocket rubbed a hole in the tube bank. So we had a tube leak about 18 months into operation, which is quite unusual. But the reason for that was readily identified and fixed. You can see there also in the image there, you can see steam coming from the blowdown tank of the heavy fuel oil plant. So you can see it's quite a busy site. You had plant operations carrying on as normal in the old plant, and the new one being built. So you can see there is a series of photographs I'll put up now, which shows the arrival of the main abnormal loads. This work was carried out. You can see the acronym ALE on the barge. The company that we used for that was Abnormal Loads Engineering. It's a UK-based logistics company. And you can see there, you can see just in the left-hand side, you can see the dolphin for the jetty, and on the right-hand side, you can see the edge of the main body of the jetty, which is accessible from the shore by a bridge. And what's missing, what you don't see there, is the steel bridge that connects the dolphin and the main body of the jetty. That's already been removed, and we removed that by unbolting it at both ends, placing a barge underneath it, and then lifting it off on the rising tide, where the bridge was lifted onto trestles. and basically then brought by barge back down to the port of New Ross. It was stored there, and it was reinstated at the end of the barging process. So the barge basically then moved in on the high tide between into the space between the body of the jetty and the Dolphin, moved close to the shore, and then was very quickly anchored in 4 ways. You can see the mooring points on the Dolphin on the left hand side. There's a mooring point on the main body of the jetty on the right hand side, and there are also 2 temporary mooring points were installed on the foreshore. So basically the barge was tied 4 ways, winched up tight so that it couldn't move. Barging operations at the station are quite dangerous. You have a very, very strong current there, so a very, very tricky operation. And then basically the barge had a ramp on the front, just dropped down onto the shore, and then you had a drive-off operation. The machines actually used, the multi-axle machines, are quite interesting. They're operated by an operator actually works off an umbilical cord, so the control cables are via a control box which is actually physically attached to the units, and the operator walks alongside. You can just see it driving off there. So basically we stored the GT under the tarpaulin there for a number of weeks until it was ready to be positioned in the building as it was being built. So that's the next image there. You can see that's the main generator transformer arriving. We used a different company, an Antwerp company for the second. First barge company was Dutch, and then we moved to a Belgian company for the transformer delivery. So you can see the same method, using a multi-axle machine to drive it off. So that's an aerial photograph of the quite recent aerial photograph of the site. You can see with the CCGT now in operation, and a number of features. We did a number of other jobs on the site. We had a lot of supplementary work we did. We had a very ramshackle security system when we were operating the HFO plant, and so we built a new security fence with CCTV and an inspection pathway all around the site, a new security hut at the entrance, and parking areas for trucks and for visitor vehicles. We did a refurbishment of the existing administration building, which we're going to keep for the future, and we did some refurbishment of the roof of the workshops. We fully refurbished the cooling water pump house building. That was covered with galvestos cladding, and all that was removed, tidied up, and new asbestos-free cladding installed. We built a small extension onto the control building that had been built for us because we needed some additional space for work issue areas and isolation offices and so on, and the first aid room. So we did that as well, and we did some work on the jetty itself after we'd finished the loading operation there. We did some civil repairs on the jetty, and general civil works around site, which was finishing off roads and footpaths and so on, and all that was done in recent times as well. So post completion, a number of other things have happened. Board Gosh have extended the gas network from Great Island onwards to Wexford Town, which is the first time we've had mains gas in that part of the country, and is facilitated by the Great Island investment. It wouldn't have happened otherwise, because it helps to defray some of the costs, so that's been a very good positive for the county. The old heavy fuel oil plant is decommissioned, so we've rendered the heavy fuel oil plant safe as far as we can. We've removed all of the potential combustibles and contaminants from the site, lube oils and so on. It's all been removed, and the site still has a number of the control points for the 110 kV grid system are actually still embedded in Great Island Station. It's a very slow process to get them out, but we're hopeful. That work is in progress. About half of the 110 control protection points that were in the heavy fuel oil plant have been moved out at this stage. We hope that process will be completed in August next year. And that's the happy moment in 2015 when we had the official opening. Just on the right hand side there, we have Alistair Phillips Davies, who's our SSE's chief executive, and Gregor Alexander, our finance officer, and the others need no introduction. I think we know who they are. So that's basically the slide presentation, and I can take some Q&A then on any of the other points that anybody wants to discuss.
Okay, Padraig, thanks very much for a very interesting presentation, as always. Hand it over to Q&A.
David Sutton from Grant Thornton. Great presentation. Just interested to know, you talked a lot about the tangible elements, the intangible elements in terms of engaging the community. What level of effort had to go in, and what was the kind of activities you had to do?
Yeah, there was a very considerable amount of work was required there, because the local community was seriously impacted by the road activity coming in. We are at the end of 5 kilometres of effectively what you would call a Boreen road. It's a very, very narrow road, and in one particular section of it, there's a section it's known locally as the causey, which is slang for causeway, because Great Island was actually originally an island until the 1930s, when a berm was built along the side of the River Barrow, and some of the land was reclaimed. So before that, at high tide, you got there by boat, and then there was a causeway that was navigable at low tide. So that the wall and that structure is all still there. It's actually a preserved structure, and that's effectively a one-way lane at that point. So locals living in the area were heavily impacted by traffic. We had a lot of issues. We had a lot of protests. There was an activist group, which was a local activist group, and we had a lot of protests, which basically people had problems with different things that were happening. They would block the road. I would say that in the course of the 3 years of the construction, and actually maybe in the year 18 months before we even commenced construction, we probably had about 10 or so disruptions, actually, when the road was blocked completely, which blocked contractors, it blocked even the operational staff from the heavy fuel oil plant, the existing operating plant. So what we did we worked very strongly with the local community. I have to pay particular tribute to the project managers who worked on the job, Peter Gavigan and Drew McAdam, who worked on the job and who put in Trojan work. And what we did was we engaged very strongly with the local community. We set up a contact group so we could have locals living in the area, local representative, and ourselves could meet and talk through issues. And we had a number of initiatives. Because of the risk of traffic, we financed the school bus run. So it was a supplementary school bus run service to make sure that the kids in the morning, there was a collection point where parents would drop their kids off in the school bus, which was exposed to the road traffic. So in order to deal with that problem, we put in place a measure whereby we paid a supplement for the bus company, which is contracted to the Department of Education. Basically, that they provide a supplementary service that actually pick up the kids at their houses right the way down the road, which eliminated that risk, and people were very, very happy with that service. It was very, very popular and very practical safety initiative. And then the other thing that was positive too as well was staff. Like, this is very much an international project with a lot of international contractors, people, but there was a great footprint in the local areas. A lot of locals, when I say locals, people literally within 100 yards of the gates of the power station actually got work in the construction phase, and we're quite happy with that. So again, it was a very strong international project, but huge input from companies and individuals in the southeast. I'd say that we didn't keep any statistics or like who was coming from where or anything like that, but I would say anecdotally, I'd say 60 to 70% of everybody who worked, of that 1,200 that I mentioned there, were actually people from Wexford and the southeast area who were primarily working on it. So that was very positive. So that's basically, there was an issue, and it was dealt with by engagement.
Jerry Duggan, Academy of Engineering, very enjoyable lecture. Just to remind people how technically astute our politicians are, I go back to the original opening of Great Island. And at that stage, the various politicians were brought around the site, and one, long since departed, but a colleague of the Taoiseach who was there, Sir Anthony Esmond, inquired where the refined fuel came out at the end of the process. He thought he was at an oil refinery. The question I have also relates to oil. As somebody who's been involved in doing fuel supply security studies in the past, I was concerned at the specification issues you identified in terms of the gas oil, because effectively the presumption to date has been that in the event of a gas supply interruption, the fuel can be replaced within the kind of storage period that's available. Now, what you're saying is clearly that will not be possible in the case of your installation, and I wonder, is that fuel quality issue more widespread than your particular plant?
Yeah, it's a very good question, Jerry. In specific response to the question, I don't know. I certainly believe it's probably an issue for Mitsubishi machines, because it's a spec for the Mitsubishi plant. The issue is it's a complicated issue, because if you take the plant as it is at the moment, we keep 5 days of fuel, and in the event of some kind of international emergency or something like that, I mean, we will be out of fuel in 5 days. So the logistics of getting a ship, getting a shipment of oil in, getting it into the port, and actually to the jetty and discharging it. I mean, it takes 2 days to discharge a full tank full of fuel anyway. Like, so you've only got 5 days in the tank anyway. So what you'll be talking about, if you're talking about standing by CCGT plants, you'll be talking about having much bigger reserves, and you're quite correct, of a type that is more usual, like some kind of standard road diesel rather than specific specification. It's a very good point.
Sorry for Billy Condon, ESB. Just on the imminent DS3 and the challenges regarding DS3 and conventional generators. As a station manager yourself, what do you think are the main challenges from an operational and maintenance point of view for the station?
Well, the main challenges going forward will be the impact of operating CCGT plants that are designed effectively as base load stations, like particularly when you don't have a bypass or you can't go into open cycle operation. So you have to operate the plant in a market that's requiring you to do things, or might require you to do things that wasn't, I suppose, strictly in the machine's original specification or design. So you're going to be talking about a lot of startups. So key business driver for us is starting reliability. If we achieve low starting reliability and fail to start when National Control Centre calls us, where we're out of the market, and that's particularly, it's going to become more acute in the future with ISEM, where a smaller amount of your income is going to be coming from capacity payments. So if you for instance have a fail to start at the moment, you will take a hit from that. So you lose your place in the market, you lose sparking, you lose the energy payments. You will lose capacity payments, but only until such time as you can make yourself available again. So you might be called or you might not be called. But in the future, when more of the income will be riding on actual energy payments and less on capacity, then starting reliability and being able to start a complicated CCGT plant is actually one of the key issues, really, in terms of operating the plant. Then you're going to be cycling the plant, so you start up, shut down. You're putting more wear on more cycles on pressure components and so on. So that becomes more tricky. I would say that's one of the major issues. The other issue is making the plants more flexible, and that's things like trying to achieve greater turn down, so you can operate the plant at a lower minimum generation, which enables grids to bring on more wind, more renewables. The other thing I think we're probably going to see more as well is grid direct and rapid modifications of load. So you're going to have things like frequency driven fast wind backs and even intertripping is going to become a feature, particularly if we're exporting wind power to the UK market. And if we were a problem with the interconnector, you're going to have rapid frequency fluctuations. So a large part of the future is going to be the ability of the CCGT plants and other plants to accommodate rapid frequency changes. And certainly we've made a lot of progress in that, and the control systems that we have in the CCGT plants compared to say what we had in the old HFO plants are radically different. It gives us a lot more capabilities to do that.
Jim Cronin, is it operating? Yes, it is. Padraig, I think you've answered, to Billy's question there. You've answered the question I was going to put on a good description of the operating regime you currently have and that which you anticipate in the future. But I have another question, and that is the question of the contractual structure that you had for the plant it was not a turnkey EPC contract.
Yeah.
Who did the interface engineering, and what was your overall experience with that type of contract?
Yeah, well, the interface engineering was done by the project team. So we had a lot of the original work was done by Endesa's own engineering team in Spain. So at the time when SSE became involved, a lot of work had been done in Spain, and that work passed over to SSE's team, SSE's engineering team in 2012. They took over the reins on a lot of that. There was also a project team had been appointed by Endesa, and a number of people associated with that. As part of the takeover agreement when SSE took over the project, a number of those people stayed on for the duration of the project. And we also had a lot of assistance. We had contracted ESBI in, and they worked on that. A lot of people who subsequently worked on the Carrington project in the UK, Sylvester Byrne and a few people like that were heavily involved in the commissioning phase and in managing a lot of the interface stuff or supervising as owners, engineers, supervising a lot of the interface issues.
And what was your experience with that type of contractual structure? Would you recommend it?
If you had a choice between an EPC and kind of effectively like a home self-build that happened in this case, I would, my personal recommendation would be for an EPC type contract, because the risk is managed by the interface risk is managed by the EPC contractor. With that sort of contract that we had, the risk is passed over more to the client. And it's not ideal, because if you have a problem, one company could say it's the other company's issue, and where you have an interface, it's better not to have these type of interfaces at all. But for that said, it worked, and we had a very good team of people who put a lot of hours in and made it work.
Jerry Devlin again. I understand that you are perhaps the only company at this stage, or the only unit that has met the new kind of rock of desires of air grid. Is that just because of the characteristic of the plant, or was it just because of the contractual situation you were in at the time?
Well, we did. It's probably Jerry, due to an issue of timing, because we were when we were doing we had first fire in September 14, and we went commercial in April 15. So when we were doing the grid code acceptance testing, the rock-off requirements were actually built into the testing. So we were probably one of the first units to be exposed to those requirements. And actually, because we were in the commissioning phase, because we're commissioning the unit, we actually did the testing and did the acceptance testing. So it's a question of I suppose timing and how it came about.
And did it create any
It's basically just done. It's just modifications to the DCS. It's done through the DCS system.
Des Murphy, Covara. Could you tell me what the efficiency of the new plant is and how it compares to the plant it replaced and how it compares to plants of its type in Ireland?
Yeah, the LHV efficiency we're currently getting is probably it's between 57 and 58%. Varies very slightly, obviously, with SCP conditions. That will compare to on the old plant probably around 30%.
Keith Elliott, PM Group. First of all, Padraig, congratulations on a very interesting talk. The logistics of the site in particular blows my mind, having previously been involved with the Corrib gas project where we had a similar situation, but Shell paid Mayo County Council to widen 12 kilometres of the road, so we didn't have any of the problems that you had there. It's very impressive. Couple of questions for you. First of all, on the civil and building side of things, I'm guessing from what you've said in answer to another question that that design was probably done under Endesa's initial phase, more or less, yeah.
Yes, yeah.
And then the local civil contracting, was that all organised by Dragados
Yes.
with local contractors and so on?
It was all organised by Dragados. It was through Dragados.
Yeah.
Dragados caught the main CISCs were Dragados' main Irish subcontractor.
And one final one then, coming back to the question about EPC versus other methods of doing things. It's very interesting that you took that on to do what we would call EPCM. And EPCM is very much our stock in trade and something that we find generally hard to sell to the power sector because the EPC model is so well established. And I'm just interested to know whether you've got any comparative figures to say that, you know, despite the fact that you were handling additional risk and so on, did it, in your view, cost you less or more to do it that way? Because we've always sold the notion that with EPC, you give away the risk, but you pay a premium to achieve that.
It's very difficult to say. I wouldn't be able to put figures on it in reality. I suppose it's really a question of where it will impact you. I would say is really in the area of schedule. If you can achieve through EPC, if you can achieve schedule control and get generating, you know, you're then immediately in the market and you're making revenue. I think that's probably one of the biggest issues. It's how soon can you get the plant operational and finished. You probably have fewer schedule risks when you do it in an EPC mode rather than EPCM. But as I say, it depends. I wouldn't be able to, in this case, I wouldn't be able to make a comparison because the way it was done was a feature of the situation that we faced at the time.
Kevin O'Rourke, thanks very much, Padraig, for an excellent presentation. Two fairly basic questions. The first one, just on the arithmetic, I'm assuming that the predecessor station there was basically retired and that, you know, you were dealing with, so basically what you've done is you've added something like 460 megawatts to the system. Do you, and in the context of the DS3 answers you gave earlier, do you know, maybe this isn't a fair question for you, maybe somebody else can answer, but do you know what the system impact of that addition has been in terms of what's it displacing essentially, yeah, or is there is there actually a spillover to export, or what's happening there in terms of the merit order? And the second question, just briefly, is with reference to the protests that you talked about. Were they specifically driven by concerns about the construction phase, or did they extend beyond that to, say, for example, grid reinforcement issues?
I suppose the first question, I wouldn't have figures, if you like, as to say like the displacement that's caused, or say if specific units or competitors are being displaced, as I wouldn't have that information. We did a study in SSE. We studied the market impact in terms of the overall benefits to market, but ultimately it's benefits to consumer in terms of having additional high efficiency capacity on the market. And our value estimate of that was 50 million euros per annum benefit to the customer. But again, I say how that's made up, or who who's being displaced, or less efficient plant being moved to the sidelines, I wouldn't be able to answer that. I suppose as regards the local community aspect of things, the focus of the protests were really very, very local issues, and it was concerns about the road, it was concerns about traffic, and it was also economic concerns that people locally in the area felt that they should have a share of what was going on in terms of a reasonable shot at economic participation, in other words, jobs in the construction phase. And unfortunately, like as things developed, that did happen, and people locally were involved, and that really helped to deal with the situation. As I say again, I pay tribute to Peter Gavigan and Drew McAdam, who put a lot of work in it. There's a lot of stakeholder, very kind of hands-on stakeholder meetings, like meeting with people and making things happen. So that was dealt with very well. So it is. I don't know whether that learning or that knowledge is transferable to other projects. I think every location is different, and the people are different, and the situations are different.
Okay, Park, thanks very much. So, but just before thanking Park, I'd like to bring everyone's attention to our final lecture of the year, which will be on the 7th of June, Wednesday, 7th of June, entitled Towards Energy Self-Sufficient Wastewater Treatment Plants, and that'll be here in Clyde Road. So listen, to finish up, the numbers mightn't be fantastic tonight, Park, but I think the level of Q&A was testament to your presentation and the knowledge you have of the site. So maybe just to finish up by thanking Park, and hello.
Thank you very much.
Cheers.
Thank you.